Welcome to Backstage, the behind-the-scenes series from Environment Variables, where we take a look at the Green Software Foundation's key initiatives and working groups. I'm the producer and host, Chris Skipper. Today, we're shining a spotlight on the Green Software Foundation's Software Standards Working Group. This group plays a critical role in shaping the specifications and benchmarks that guide the development of green software. Chaired by Henry Richardson, a senior analyst at WattTime, and Navveen Balani, managing director and chief technologist for technology sustainable innovation at Accenture. The group's mission is to build baseline specifications that can be used across the world, whether you're running systems in a cloud environment in Europe or on the ground in a developing country. In other words, the Software Standards Working Group is all about creating interoperable, reliable standards, tools that allow us to measure, compare, and improve the sustainability of software in a meaningful way. Some of the major projects they lead at the Green Software Foundation include the Software Carbon Intensity Specification, or SCI, which defines how to calculate the carbon emissions of software. The SCI for Artificial Intelligence, which extends this framework to cover the unique challenges of measuring emissions from AI workloads. The SCI for Web, which focuses on emissions from websites and front-end systems. The Real-Time Energy and Carbon Standard for Cloud Providers, which aims to establish benchmarks for emissions data and cloud platforms. The SCI Guide, which helps organizations navigate energy, carbon intensity, and embodied emissions methodologies. And the Transforming Organizations for Sustainable Software, or TOS framework, which offers a broader blueprint for integrating sustainability across business and development processes. Together, these initiatives support the Foundation's broader mission to reduce the total change in global carbon emissions associated with software, by prioritizing abatement over offsetting and building trust through open, transparent, and inclusive standards. Now, for some recent updates from the working group. Earlier this year, the group made a big move by bringing the SCI for AI project directly into its core focus. As the world turns more and more to artificial intelligence, figuring out how to measure AI's energy use and emissions footprint is becoming a priority. That's why they've committed to developing a baseline SCI specification for AI over the next few months, drawing on insights from a recent Green AI Committee workshop and collaborating closely with experts across the space. There's also growing interest in extending the SCI framework beyond carbon. In a recent meeting, the group discussed the potential for creating a software water intensity metric, a way to track water usage associated with digital infrastructure, especially data centers. While that comes with some challenges, including limited data access from cloud providers, it reflects the working group's commitment to looking at sustainability from multiple environmental angles. To help shape these priorities, they've also launched a survey across the Foundation which collected feedback from members. Should the group focus more on web and mobile technologies, which represent a huge slice of the developer ecosystem? Should they start exploring procurement and circularity? What about real-time cloud data or hardware-software integration? The survey aims to get clear answers and direct the group's resources more effectively. The group also saw new projects take shape, like the immersion cooling specifications, designed to optimize cooling systems for data centers, and the Mycelium project, which is creating a standard data model to allow software and infrastructure to better talk to each other, enabling smarter energy-aware decisions at runtime. So, that's a brief overview of the Software Standards Working Group, a powerhouse behind the standards and specs that are quietly transforming how the world builds software. Now, let's explore more of the work that the Software Standards Working Group is doing with the Software Carbon Intensity Specification, the SCI, a groundbreaking framework designed to help developers and organizations calculate, understand, and reduce the environmental impact of their software. The SCI specification offers a standardized methodology for measuring carbon intensity, empowering the tech industry to make more informed decisions in designing and deploying greener software systems. For this part of the podcast, we aimed some questions at Navveen Balani from Accenture, one of the co-chairs of the Software Standards Working Group. Navveen rather graciously provided us with some sound bites as answers. My first question for Navveen was about the SCI specification and its unique methodology. The SCI specification introduces a unique methodology for calculating carbon intensity using the factors of energy efficiency, hardware efficiency, and carbon awareness. Can you share more about how this methodology was developed and its potential to drive innovation in software development?
Thank you, Chris. The software carbon intensity specification was developed to provide a standardized, actionable way to measure the environmental impact of software. What makes it unique is its focus on three core levers: energy efficiency, hardware efficiency, and carbon awareness. Energy efficiency looks at how much electricity a piece of software consumes to perform a task. So writing optimized code, minimizing unnecessary processing, and improving performance all contribute. Hardware efficiency considers how effectively the software uses the infrastructure it runs on, getting more done with fewer resources. And carbon awareness adds a critical layer by factoring in when and where software runs. By understanding the carbon intensity of electricity grids, applications can shift workloads to cleaner energy regions or time windows. The methodology was shaped through deep collaboration within the Green Software Foundation, involving practitioners, academics, and industry leaders from member organizations. It was designed to be not only scientifically grounded, but also practical, measurable, and adaptable across different environments. What truly sets SCI apart and drives innovation is its focus on reduction rather than offsets. The specification emphasizes direct actions that teams can take to lower emissions, like optimizing compute usage, improving code efficiency, or adopting carbon-aware scheduling. These aren't theoretical ideas. They're concrete, easy-to-implement practices that can be embedded into the existing development lifecycle. So SCI is more than just a carbon metric. It's a practical framework that empowers developers and organizations to build software that's efficient, high-performing, and environmentally responsible by design.
The SCI encourages developers to use granular real-world data where possible. Are there any tools or technologies you'd recommend to developers and teams to better align with the SCI methodology and promote carbon-aware software design?
Absolutely. One of the most powerful aspects of the SCI specification is its encouragement to use real-world granular data to inform decisions. And there are already a number of tools available to help developers and teams put this into practice. A great example is the impact framework, which is designed to make the environmental impact of software easier to calculate and share. What's powerful about it is that it doesn't require complex setup or custom code. Developers simply define their system using a lightweight manifest file, and the framework takes care of the rest, calculating metrics like carbon emissions in a standardized, transparent way. This makes it easier for teams to align with the SCI methodology and track how their software contributes to environmental impact over time. Then there's the Aware SDK, which enables applications to make smarter decisions about when and where to run, based on the carbon intensity of the electricity grid. This kind of dynamic scheduling can make a significant difference, especially at scale. There's also a growing body of green software patterns available to guide design decisions. The Green Software Foundation has published a collection of these patterns, offering developers practical approaches to reduce emissions by design. In addition, cloud providers like AWS, Microsoft Azure, and Google Cloud are increasingly offering their own sustainability-focused patterns and best practices, helping teams make cloud-native applications more energy efficient and carbon aware. And for those looking to explore even more, the awesome green software repository on GitHub is a fantastic curated list of tools, frameworks, and research. It's a great place to discover new ways to build software that's not only efficient, but also environmentally conscious. So whether you're just starting or already deep into green software practices, there's a growing ecosystem of tools and resources to support the journey. And the SCI specification provides the foundation to tie it all together.
Looking ahead, what are the next steps for the Software Standards Working Group and the SCI specification? Are there plans to expand the scope or functionality of the specification to address emerging challenges in green software?
Looking ahead, the Software Standards Working Group is continuing to evolve the SCI specification to keep pace with the rapidly changing software landscape. And one of the most exciting developments is the work underway on SCI for AI. While the existing SCI specification provides a solid foundation for measuring software carbon intensity, AI introduces new complexities, especially when it comes to defining what constitutes the software boundary, identifying appropriate functional units, and establishing meaningful measurements for different types of AI systems. This includes everything from classical machine learning models to generative AI and emerging AI agent-based workloads. To address these challenges, the SCI for AI initiative was launched. It's a focused effort hosted through open workshops and collaborative working groups to adapt and extend the SCI methodology specifically for AI systems. The goal is to create a standardized, transparent way to measure the carbon intensity of AI workloads, while remaining grounded in the same core principles of energy efficiency, hardware efficiency, and carbon awareness. Beyond AI, there are also efforts to extend the SCI framework to other domains, such as SCI for Web, which focuses on defining practical measurement boundaries and metrics for web applications and user-facing systems. The broader aim is to ensure that whether you're building an AI model, a backend service, or a web-based interface, there's a consistent and actionable way to assess and reduce its environmental impact. So the SCI specification is evolving, not just in scope, but in its ability to address the unique challenges of emerging technologies. It's helping to create a more unified, measurable, and responsible approach to software sustainability across the board.
Thanks to Navveen for those insightful answers. Next, we have some events coming up in the next few weeks. First, starting today on July 3rd in Mannheim, we have Developer Week 2025. Get sustainability-focused talks during one of the largest software developer conferences in Europe. Next, we have Green I/O Munich, which is a conference powered by Appy Days, which is a conference happening on the 3rd and 4th of July. Get the latest insights from thought leaders in tech sustainability and hands-on feedback from practitioners scaling green IT. In the UK, in Brighton, we have Evolve 25, Shaping Tomorrow, which is happening on July the 4th. Explore how technology can drive progress and a more sustainable digital future. Next up, on July the 8th from 7 to 9 p.m. CEST in Amsterdam, we have Grid-Aware Websites, a new dimension in sustainable web development, hosted by the Green Web Foundation, where Farshad Irani will talk about the Green Web Foundation's latest initiative, Grid-Aware. Then next week, Wednesday, there's a completely virtual event, Master JobRunner V8, a live coding webinar, July the 9th. Sign up via the link below. Then also on Wednesday, on the 9th of July in Berlin, we have the Green Coding Meetup, Blauer Engel for Software, Carbon Aware Computing, happening from 6:30 p.m. Then on Thursday, July the 10th, from 6 p.m. to 8 p.m. CEST, we have Shaping Progress, Responsibility, AI and Sustainability in Frankfurt. Then finally, on Tuesday, July the 15th, we have a hybrid event hosted by Green Software Development Karlsruhe in Karlsruhe, Germany, which is entitled Green Data Center for Green Software for Green Data Center. Sign up via the link below. So, we've reached the end of this special Backstage episode on the Software Standards Working Group and the SCI project at the GSF. I hope you enjoyed the podcast. As always, all the resources and links mentioned in today's episode can be found in the show notes below. If you're a developer, engineer, policy lead, or sustainability advocate and you want to contribute to these efforts, this group is always looking for new voices. Check out the Green Software Foundation's website to find out how to join the conversation, and to listen to more episodes about green software, please visit podcast.greensoftware.foundation, and we'll see you on the next episode. Bye for now.